Welcome to The Explainer. Today, we're diving into something pretty cool and, honestly, really important, a mathematical blueprint for AI safety. It's called CAST.
So here's the big one, right? How do you actually control an AI that can write its own code and surf the web? I mean, we've got these models now that can do all that. They can run code, they can browse, they can interact with pretty much anything digital. And while that's amazing, it's also, a huge safety headache.
The real problem here is feedback. Think about it. An AI does something, like a web search, and that action changes the world it sees. And that change, it feeds right back into the AI's next decision. You get these wild, unpredictable feedback loops. And that unpredictability, that's the danger. It's exactly what this new framework, Certifiable AI Safety, or CAST for short, is designed to tackle.
All right, so here's how we're going to break this down. First, we'll look at the specific danger we're up against. Then, we'll get into the core idea behind CAST, which is all about, believe it or not, geometry. From there, we'll see how it actually works in real time, how it stays tough in a messy world, and finally, what all this fancy math actually proves.
Okay, so first things first, let's talk about AI's dangerous new power.
Now, let's be super clear here. CAST isn't about stopping some kind of, sci-fi robot takeover. It's laser-focused on digital worlds. We're talking about high-stakes environments like finance, automated trading systems, or even complex scientific computing. These are places where just one bad digital move can cause massive, cascading problems.
All right, so now that we know the problem, let's get to the solution. And this is where it gets really elegant. The core idea is all about what's called safety geometry. This right here, this is the absolute heart of it. See, instead of trying to play whack-a-mole and block every single bad thing an AI might do, which, let's be real, is impossible, CAST flips the script. It does something way smarter. It uses some pretty advanced math to define an entire safe zone of things that are okay.
And this image, this shows the whole idea perfectly. So the AI suggests an action, that little red cross, and oops, it's outside the green safe zone. But here's the cool part. CAST doesn't just block it. It actually calculates the closest safe alternative and gently nudges the action back inside the zone. That's the blue arrow. So it's not just blocking, it's correcting. A huge difference. Okay, so this geometric safe zone is a really elegant idea. But how do you actually make it work, second by second? Well, that's the job of something called the CAST safety gate.
You can think of it like a security checkpoint, but for AI decisions. It happens super fast for every single thing the AI wants to do. So the AI proposes something. CAST immediately monitors it. It checks for a safety certificate, basically asking, is this okay? And then based on the answer, the action either gets the green light, gets fixed on the spot, or gets swapped out for something else entirely. So what happens if an action gets rejected? Well, the system has two main moves. The first is repair. That's the cool projection thing we just saw, where it nudges the action back to safety. The second option is replace, which is even more straightforward. It just says, nope, not doing that, and swaps it with a pre-approved safe move, like doing nothing, or in a trading scenario, just not making a trade. Okay, this part is really clever, how it actually monitors the AI. It's super flexible. If you can see inside the AI's brain, its code, that's called white box. You can just calculate if an action is safe directly. But what if you can't? For a black box AI, it uses this slick statistical trick to sort of test the AI's intentions without seeing the code. And for actions that use tools, like running a script, it can do a dry run in a safe little sandbox to make sure the result is okay before letting it happen for real. So a safety theory on paper is great, but the real world is messy, right? A system has to be tough. So how does CAST make sure it's robust enough for reality? One of the sneakiest problems in safety is this idea of death by 1,000 cuts. It's when a lot of tiny, seemingly harmless risks slowly add up to one big disaster. CAST has a brilliant way of dealing with this. It gives the AI a risk budget over time. Basically, it tracks all the little risks and makes sure that the total accumulated risk never, ever crosses a hard limit.
And it doesn't just look at the present either. AIs can change. Their behavior can drift over time. What's amazing is that CAST can actually anticipate this. It calculates the worst-case scenario for how the AI might change, and then it builds in a big enough safety buffer from the start. It's all about staying one step ahead to keep things inside that safe zone.
And this is a really crucial point. This whole system isn't just for one single AI. It's modular.
That means you can take a bunch of different components, say a large language model, a code interpreter, a web browser, and plug them all together. CAST lets you certify the entire system as safe, not just the individual pieces. That's a huge deal.
Okay, let's circle back to those feedback loops we talked about at the beginning. Remember? When an AI's actions influence its own next move. The problem is, most standard statistics just can't handle that. They assume events are independent. Well, this is a major breakthrough. CAST uses a more advanced kind of math that's built for these kinds of chain reactions. And that's the secret sauce that makes the safety guarantee actually work, even when the AI is constantly evolving.
So we've got the safety geometry, we've got the gatekeeper, and we've got the robust design to handle the real world. You put it all together, what's the bottom line? What does this actually prove? Let's make this super concrete. Imagine you have an AI that trades stocks. You can give it a simple safety rule. Do not do anything that even looks like market manipulation. Then, the CAST system stands guard, checking every single trade the AI wants to make. If it proposes something sketchy, boom, the system steps in. It either tweaks the trade to make it compliant or just cancels it with a no-trade order. It's a real, provable safety net for every single decision.
And this quote from the original paper, it just nails the whole point. The goal here isn't to pretend we can get to zero risk. That's impossible. Instead, CAST does something way more practical and powerful. It takes that scary, infinite, unknown what-if risk of a powerful AI and it turns it into a number. A finite, measurable, auditable amount of risk. You're no longer in the dark. You know exactly what you're dealing with.
So when you boil it all down, CAST is an incredible mathematical blueprint. It gives us the how to enforce the safety rules we set. It's a powerful toolkit for containment. But that leaves us, the people building and using this stuff, with the really hard question, doesn't it? Now that we have a blueprint for safety, what rules should be actually right? What do we decide is safe?